So now we're going to talk about multiplication. And let me remind you how multiplication works with just ordinary number fractions. Let's say you needed to multiply together 3/10 times 4/15. Multiplication is easy with fractions because you just multiply across the numerators, multiply across the denominators. So on top, 3 times 4 is 12. On the bottom, 10 times 15 is 150. And that is the product, but it's not in lowest terms. We can reduce this. There are things we can divide the numerator and denominator by. We might have to do a little figuring out what the greatest common factor is. But an easier way to go, if what we're looking for is the answer in lowest terms, is before we multiply stuff together, let's factor things out and look at what all the factors we're dealing with are. So we got a 3 here that can't be broken up any further. We got a 10 that's equal to 2 times 5. 4 can be factored into 2 times 2. And we can break the 15 up into 3 times 5. So now on top we've got a 3 times a 2 times a 2. And on the bottom we got a 2 times a 5 times a 3 times another 5. And then we can cancel a 3 and a 2 from both the numerator and the denominator. And then what we have left is 2 on top over 5 times 5, or 25 on the bottom. So the answer in lowest terms is 2 over 25. Now if we'd gotten this 12 over 150 and then divided the top and the bottom both by 6, that would be 2 over 25. But it's probably easier to divide things out first before you multiply it out. So that's the strategy that we're going to be using when we're multiplying rational expressions. Here's the procedure. Factor anything that you can find to factor in any of the numerators or denominators. And then cancel, that is, divide out any common factors that appear in both the numerator and the denominator. So how about this one? X plus 3 over 2x minus 4 times x minus 2 times 3x plus 5. Do you see anything we can factor here? Well, there's not much, but there is one thing. Here, this 2x minus 4, we can pull out a common factor of 2. So we can write it as 2 times x minus 2. So in the numerator, we have an x plus 3 times an x minus 2. In the denominator, we have a 2 times an x minus 2 times a 3x plus 5. And we can cancel the x minus 2's. So what we have left is x plus 3 on top over 2 times 3x plus 5 on the bottom, which you could multiply out and write as 6x plus 10. Now, I would accept either form as your final answer to a problem like this. Sometimes you like to have things multiplied out. Sometimes it's just as well to leave them in factored form. It kind of depends on what you're going to be doing with things. So for now, I would accept either one of these as your final answer to a problem like this one. Now, what about division? When you're dividing fractions, the rule is invert the divisor. That is, you leave the first fraction the way it is, but the second fraction you flip upside down so that the numerator and denominator trade places. So what you're really doing is you're changing that second fraction to its reciprocal, and then you're changing division to multiplication. So you're multiplying by the reciprocal of the second fraction. Once you've done that, it becomes a multiplication problem, and you do it the way we just talked about. Factor everything that you can in any of the numerators or denominators, and then look for any common factors that you can cancel out. So now this right here is really one fraction divided by another. You got one fraction over another fraction. So this would mean the same thing as 6x minus 18 over 2x squared plus 11x plus 5 divided by 3 over 4x plus 20. And remember what I said to do with the division? Change the division to multiplication and change the second fraction to its reciprocal, like this. 6x minus 18 over 2x squared plus 11x plus 5, first one stays the same, times 4x plus 20 over 3. So now what we're going to do is factor everything we can. If I were doing this live, this might take me a while to figure out how to factor everything. Here I'm just going to show you what the factors are. If you want to pause the video right now and see if you can do the factoring yourself, that would be great. But I'm just going to show you what you get when you factor everything. 6 times x minus 3 over 2x plus 1 times x plus 5. And then here we pull out the 4 times x plus 5 over 3. Now what can we cancel? I see an x plus 5 as part of the numerator and the denominator. That's going to cancel. Anything else? Well, this 3 down here, and then we got a 6 up here that would be 3 times 2. So we could divide out the 3's, and then there would be a 2 left here. So instead of 6 over 3, we would just have a 2 on top over 1. So when we do all of that, what's left is this 2 times this 4, which is 8, times this x minus 3. That's what's on top. And on the bottom, we just have this 2x plus 1. So our final answer we can write either as 8 times the quantity x minus 3 over 2x plus 1, or, multiplied out, 8x minus 24 over 2x plus 1. Okay, how about this one? We're back to multiplication, so we are not doing any flipping. This is already set up as a multiplication problem. So we're going to go ahead and factor everything we can. Again, I'm going to skip right to what the factors are, but if you want to pause the video, see if you can see what the factors are going to be, that would be great. So here is the factored form of all of this. I can pull out a 4 here, so it's 4 times a plus 2. Don't forget to look for common factors. I can pull out a 9 down here, 9 times a plus 1. A squared minus 1 is a difference of 2 squares, so I can break that up into a plus 1 times a minus 1. And then 2a plus 4, I can pull out a 2 times a plus 2. Okay, now for the fun part. Now we can go canceling stuff. What can we cancel? What can we get rid of here? What cancels? I see the a plus 2's on top and on the bottom, and a plus 1 on top and on the bottom, and, well, there's a 4 over a 2 that would reduce to like a 2 over a 1. So 2 times a minus 1 over 9 is what we have left. Okay, how about this one? 6x squared minus x minus 35 over 2x squared minus 3x minus 5 divided by 3x squared plus x minus 14 over x squared minus x minus 2. What do we do first? This is division. We start by changing division into multiplication of the reciprocal of the second fraction. So first fraction stays the same, and then it's times x squared minus x minus 2 over 3x squared plus x minus 14. What is the next step? What do we do next? Next, we go all factoring on everybody. So factor this, factor this, factor this, factor this. Turns out what we get is 3x plus 7 times 2x minus 5 over 2x minus 5 times x plus 1. And then over here, x minus 2 times x plus 1 over 3x plus 7 times x minus 2. And do you see anything we can cancel? Okay, here's where we go canceling stuff. 3x plus 7's, 2x minus 5's, x minus 2's, x plus 1's. Look at that! Everything canceled! So what's left if everything cancels? When you cancel everything, what do you have left over? 1. Basically, we have everything on top divided by that same thing on the bottom. When you divide everything out, what's left is just plain 1. So this fraction divided by this fraction always just comes out to be 1, no matter what number you stick in for x. Okay, so that's it for multiplication and division. I'm going to end this video here and then come back in the next video and we'll talk about adding and subtracting rational expressions.